Okay, I'm gonna do the best I can here. I did a whole video and my microphone wasn't working well, and hopefully this one works okay. Um, so I'm gonna do problems 1 and 2 on this video. I'm gonna do another video that'll do problems 3 through 6. So I'm gonna start actually with 1 part 1. Sorry, I've got 1 part 2 on here. Okay, so 1 part 1, the whole point of the first thing is to see if you can split a fraction into partial fractions. So remember the technique we have to do that is if I want to find a, I'm going to multiply both sides of this equation by 2x minus 1. Notice that's going to make that go away. B and C are going to both be multiplied by 2x minus 1, but then I'm going to make those go away by plugging in a negative 1/2 for x. So it's basically going to take that away. That'll be gone. Over here, this will be gone. And I'm going to plug in negative 1/2 for x. Here's the work of me doing that for A. For B, I'm going to multiply both sides by x minus 2 squared, which is going to make this go away. I'm going to be able to get rid of these two terms by plugging in 2 for x. And that's my work doing that there. There I have B. All right, now remember I can't do that to get C, because if I just multiply both sides by x minus 2, I can't make the B term go away, because if I plug 2 in here, I plug it into I make the denominator equal 0. Okay, so what I have to do to find C is plug in my A and B, and then plug something else in for x. So I plugged in my A and my B. All right, otherwise I rewrote this equation completely. There's A, there's B. All right, and then I plug something else in for x. In this case, what I'm going to plug in is 0. So I plugged 0 in here, and you can kind of see my work here. I simplify down. I get 4 over 4 on the right side, which I simplified down to 1, and then I just solve it down to get C. Okay, so that's how I get those parts. Now listen, if I'm going too fast, just pause this video and then check my work, because it's all shown on my paper here, but you can look back. All right, for 1 part 2. All right, so here's where I'm guessing most of you had problems on this 1 part 2 and 2 part 2. All right, so look, here's my fraction rewritten as partial fractions. Now, the thing to remember is that this term can be rewritten like this. 2x plus 1 to the negative 1. This can be rewritten as 8 times x minus 2 to the negative 2, so on and so forth. All right, before I can do binomial expansion, I have to make sure that things are written in the right way. Now, fast forward and look at problems 3 and 4 if you want to see some more specifics on how to make that happen. But basically, I need to have it where it's 1 and then plus or minus some term with an x here. So the first term's easy. I can just change the order these are written in, and I'm in a place where I can do the binomial expansion. Here, when I switch the terms, though, I don't have a 1 as my first term, which I have to have. So I got to factor that out. But I can't just factor out a negative 2 because of this exponent. So what I need to do is factor out a negative 2 to the negative 2. Negative 2 to the negative 2 is actually equal to 1/4, and 1/4 times 8 is 2. So that's where this coefficient comes from. Once I factor this negative 2 out of here, that's what my term becomes, and that's what I'm going to do the expansion on. Again, if I'm going too fast here, pause the video, look at my work, and you can probably figure out what's going on. Okay, now what I did down here is I'm going to expand each of these sort of separately. So here, I did the expansion of my first term. And then here's my expansion of my second term. Here's my expansion of the third term. Notice I left the coefficients out front. And then I just combined my like terms. So to get this 1 is actually 1 plus 2 minus 2. All right, and then I've got a negative 2x plus 2x, which zeroes out. And then when I multiply here, I get negative 1x. All right, same thing for these to get the 5x squared. Okay, for question 2, I'm only going to do part 2. All right, look back or work with somebody to do the split it into partial fractions. But here's what it looks like when it splits into partial fractions. Okay, something like this. You can have these written in a different order, but that's the fractions that you need to have. All right, these can be rewritten like this. All right. Now, I skipped a step here in showing like what I factored out here. But here, I'm going to have to factor out a -2. And here, I'm going to have to factor out a -1. Because when I rewrite these, I'm going to have -1 plus x, and this is going to be -2 plus x. But when I factor those things out, here's what I should get. Okay, and if you need to step through, look, and kind of do that on your own to see, here's what you should be getting. Okay, now as I do the expansion of that one, I get that. The expansion of this one, I get that. And the expansion of this one, I get that. All right, and then when I just combine all my like terms, there are the terms that I get for my final expansion of into part 2. Okay, I actually may have some more time or more space here on the video, so I'm going to keep going. And here's number 3. Okay, so here's where I'm actually doing a binomial expansion. It's expanded out a little bit more. So this is good to go. 1 is my leading term, and then this is something with an x. Remember, this needs to be a rational number that's not positive. That's not a positive integer. Okay, so first term's always 1. Next term is always my exponent times that term. So my exponent times that term. My next term is my exponent times my exponent minus 1. So this is -1/2, this is -1.5, all over 2. And then times my second term squared. Okay, third term, exponent, exponent minus 1, exponent minus 2, all over 6, or 3 factorial, times my second term cubed. Okay, reducing these down, simplifying these down, gives you those terms. Okay, and if you're running into trouble here, just always remember you got to square this coefficient before you can multiply it by this. All right, that's where people run into trouble. All right, number 4. Okay, so number 4, we run into the trouble of this first term is not a 1. We need it to be. So we got to factor out this 2. But remember, when we're factoring out a 2, it's really a 2 to the -2. Okay? So you can think about these terms as just having a 2 taken out of them, but when I took it out of there, it really had that -2 to that power. So this really needs to get simplified down to this before you can do the binomial expansion. Okay, now we're pretty fortunate here. We only have to go up to x squared, so we only have to do 3 terms here, and the first term is always 1. So here's my work for those all expanded out and simplified, and you should get down to that as your answer. Okay, and again, pause and check it over if you need to. All right, number 5. So number 5, we need to split it into partial fractions first, and you can sort of see my work here. This one's pretty easy. The weird thing about this is that we get fractions as my coefficients on top. Okay, but it's really okay because remember the derivative of some constant over y is just that constant times the natural log of y if I'm doing the integral. Okay, and the integral again of some constant over 4 minus y is negative that constant times the natural log of 4 minus y. Now remember, if you're wondering why this switched, it's because we have to do chain rule. So remember, you always, like when I did this first, I said, oh, plus 1/4 natural log 4 minus y. But when I do the derivative, it's going to be 1/4 over 4 minus y, but then I got to multiply it by -1 because the derivative of this is -1. So I have to readjust what my guess at the integral was to make that negative. And then you can check to see that the derivative of that term is this. Okay? And then number 6. All right, so 6, we first have to split into partial fractions. You can see my work for that up there. Pause it if you need to look over that. Okay, once I have it split into partial fractions, now I won't need to do the integrals of each of those terms. So the integral of that is just natural log of x plus 1, because the derivative of x plus 1 is just 1. And then here, we just have 2 times the natural log of x minus 2. Again, the derivative of this is 1, so we don't have to adjust this at all. Okay, now we just evaluate it. We plug in the 4, and then we plug in the 3, and we subtract.